.NET 7 and Azure Modernization with Jimmy Bogard.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. This podcast is sponsored by ClearMeasure, a full-service software architecture and engineering firm empowering software delivery for business-critical software projects, project delivery, and team empowerment using the ClearMeasure way for effective software projects. Quick announcement, my architect forums are going strong and signups for the next session are up. And if you lead a software team and are looking to collaborate with peer architect leaders, then just go ahead and sign up at the link that are in the show notes. And for those of you who are looking for Programming with Palermo, my video podcast, just search for it in any of the podcast directories and you'll be able to find it. Now, my guest today on the show, returning guest, is Jimmy Bogard. Jimmy is the creator and maintainer of the popular open source libraries AutoMapper and MediatR, and he's an independent consultant based in Austin, Texas. And he's also received the Microsoft Most Valuable Professional Award, MVP, every year since 2009. And of course, longtime friend and co-worker and co-author of a past ASP.NET MVC book with me. So, Jimmy, welcome to the show. Great to have you.
Great. Good to be back.
Absolutely. My pleasure indeed. And it was good to see you in person at the Kansas City Developer Conference just a couple of months back. You're speaking at so many conferences. Those are always fun.
I know. Yeah, I actually just got back from the DevOps Conf in St. Louis. And I left here in Austin and it was 108 and I landed in St. Louis in the 78. It was amazing.
Perfect. Yes, absolutely. Yeah, I think hopefully, we're both in Texas. Hopefully the hot part of the summer is kind of trailing off. We'll see.
Yeah, we'll see.
We say that every summer. Oh, I'm surprised that summer's hot.
I know, it's 98 outside. I'm like, oh, wow, it's really nice. It's cool.
Yeah, I know. Tell you what, that Pacific Ocean volcano, though, did run a number on us for this summer. It is a little bit hotter than last year. So you've done a lot with AutoMapper and MediatR and so many other topics, but with so many new programmers, and I've talked about this, so many new programmers in the industry building new pieces of software, every one of them is going to get to a point where they inherit an old software system if they haven't already, or the code that they're building becomes what other people label as legacy, and so there's a huge volume of older .NET software and non-.NET, and people are thinking, okay, .NET 7 is the current latest, and .NET 8 is coming out in November. We want to be able to modernize this to the latest, and we want to get it off of our own servers that we're maintaining and patching and getting into Azure. So how should people be thinking about moving older .NET applications to the latest stuff?
Oh, yeah, that's basically my life for the past 12 to 14 months or so, was trying to, one, answer that question is of, what does it mean to modernize these kinds of old software systems? Is it just, get them up to the latest .NET framework, like 4.5 to 4.8, or should they be looking at, getting off of that framework altogether and getting onto, modern .NET tooling? And so a lot of what we start out with is just understanding well, what would be the impact and effort to do some sort of migration like that? So a lot of my time initially was just spent analyzing the existing applications just to understand, well, are we talking mountain or molehill here? Like what kinds of things are available for us out in the wild to help us do this kind of migration, or is it even feasible? And luckily, right when we had started the project, it was August of last year, Microsoft was releasing some tooling and some libraries to make those kinds of migrations 8,000 times easier. They're still just dead simple, but at least much, much easier. So that helped with kind of the ROI aspect of saying well, we don't have to have a huge investment to perform this migration. So it made it a little bit easier to sell, to say, we can get it done in months versus like years that these typical kind of migrations go through.
Yeah. Yeah. Okay. Now, I'm assuming that there are some pieces, because when we think about moving a system, maybe from operating systems that we maintain to Azure, there's a certain amount of work there. When we talk about older versions of .NET and coming up to the latest, and maybe different threads of work, if we have even older versions of SQL Server or databases or queuing technologies or anything, how do you divvy that up when you form an architectural plan and the sequence of things to tackle? Do you have a preferred sequence of work that you found just makes life easier when modernizing a significant system?
Yeah, I mean, I always like the idea of of going in very small baby steps and changing one thing at a time. There's something I learned early on, way back when working with you, was like, if I'm making a change and I'm making too many changes at once and something breaks, it makes it really hard to figure out, okay, what went wrong. So with both of these, like Azure and .NET 7 migration, I wanted to make sure that we had very small steps that we could validate along the way, and as much as possible minimize the dependencies between those two different work streams. So this was kind of unique in that we were doing both at once, like an Azure migration and the .NET 7 migration at the same time. And so we wanted to make sure that there was no, big bang, flip the switch sort of thing, that we could validate these steps along the way and make sure that we didn't have, as much as possible, minimize the set of dependencies between those kind of two major work streams we had going on.
Mm-hmm. Yeah. Microsoft has done a lot of work and kind of touts .NET Standard as kind of a bridge between .NET Framework and then the .NET Core, .NET 7. And there's other compatibilities, and they brought over like even older COM+ OLADB APIs into .NET 7. But in your experience, which shims and which compatibility layers actually work as intended, make life easier, and what have you tended to actually rely on?
Yeah, that was a big question that we had going for us. So like the Microsoft tooling that they came out with last year, it's called System Web Adapters. And the idea behind that is that you've got a bunch of code calling into system web junk. And that stuff doesn't exist in the ASP.NET Core land. It's all Microsoft.web.whatever. So if you're trying to port that code over, you have the choice of like, well, do I fix all that code to use the right stuff? Or what they put in their system web adapters are these shims that they support. So that if you're calling, like, one great example is HTTP context at current.
Yes.
Well, with this shim, like your code could still be calling HTTP context at current, and then depending on what platform it is on, it could either be calling the actual HTTP context current, or it'd be using like some magical thing that Microsoft put out to like mimic that behavior in ASP.NET Core land. But we had to make a choice, like, do we want to leverage those shims, or do we go ahead and refactor that code to directly target ASP.NET Core? And it was basically a spot decision every time we hit something like that, to like, okay, do we re-architect? Like, what's the effort to re-architect this versus, okay, we'll just keep the shim for now, and then once we get down the line, okay, we can put a tech debt story up there to go ahead and fix it in the future. So it's very much a kind of a case by case basis, where as much as possible we preferred re-architecting if it was feasible and wouldn't take too much time. Simply because the code that came out of it was better. Like Microsoft, the way they did dependency injection in .NET Core was built in the entire stack. So we always saw like, we're doing way less, static service location junk. Like the code was better on the other side. So like, if we can, we want to improve the architecture as we go and not try to bring things forward.
Yeah. Now, just for context, the large system you're talking about, did it have a good amount of test automation, or like many legacy systems, very little?
Well, actually, it did have, because it was actually an old Headspring project from like 2000.
Nice. Okay.
It had fantastic test coverage, but those tests were geared towards like the ASP.NET, like that way of doing things back then. And so with ASP.NET Core, everything's like, services.add blah. And so everything is DI enabled. So we do have to adjust the kind of runtime of those integration tests to make sure they ran under the kind of modern integration testing story of .NET Core versus what we had before. So again, it was just all these like, okay, what are the kind of the minimal changes we can do to migrate this code over, but still hopefully improve the architecture along the way, and don't repeat some of the old patterns that are actually harder to do going forward.
Yeah, yeah. So in the areas that maybe you found it didn't have sufficient coverage, or for other systems where the listeners may be thinking, oh, there was test coverage, man, I'm upgrading a system that has nothing.
Right.
What are the feasible options to port it to a situation where the modernized version actually has some useful test coverage? When you're in that situation, the whole red green refactor, write them as you go, unit test, that it really doesn't work in that world. So what are the feasible options to tackle that testing while
Yeah, I
reporting?
I say we had a lot of that testing sort of stuff in place, but we started putting things like feature flags in and shims to be able to have it kind of run under the normal way of running when it was running under ASP.NET Core, but then be able to put in some shims to enable testability and kind of the new way of doing things. And it's just, again, a lot of it has to do with just looking at how the existing system is designed and where those testing hooks, where those hooks could be put in place so that we could still have kind of minimal changes, but hopefully not make the system, worse than it was before. But we still had as we were migrating, we're migrating a controller at a time. That was our approach of every single controller would be all the pages from that controller, because usually they have to do with one another. So it wasn't one action at a time, it was one controller at a time. And we still had a QA person that would go through the regression tests for those pages before we'd put into production. But we would, once we were done migrating a controller, that was merged to main and put into production. So we didn't have this .NET Core branch sticking off the side for 3 months. It was every time we finished a page, we were putting it out into production to make sure, again, that it worked as intended. We didn't miss anything.
Nice. Any gotchas on the database side?
Yeah, so especially the Azure migration part of it, we initially had to decide, well, what kind of target infrastructure should we be deploying to? What resource do we pick inside of Azure? So for that piece, we, as much as possible during this migration, we wanted to pick PaaS, platform as a service-based resources, because that gives us the most scalability options.
Yeah.
But for both looking at the existing resource on hand, as well as what migration paths are available to us, we had to decide, well, what's the appropriate target for us? So that was a lot of my work, was just prototyping and researching about, well, what, for all the different SKUs of SQL that are out there, which are, they kind of range between, it's a continuum between PaaS and infrastructure as a service. On the right, you've got SQL, Azure, and VM.
Yep.
So you could just physically lift and shift your database VM up to Azure, and all the crazy features you have in there would work. But we wanted to try to target as much as possible the existing, the Azure SQL that gives you those slider-based, boop, 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 boop. You can scale up and scale down, that sort of thing. But that's what I looked at is, those migration tools available to us, what they work for us, what limitations do they have? And we found the one that was pretty good. It's from Microsoft. It's called SQL Data Sync. And one of the great things about that tool is it supported bi-directional syncing. We really liked for one, as we were testing out the app in Azure, there's just going to be random little things of oh, whoops, we'd had hard-coded paths in our database, and we didn't realize that. So you go load someone's profile and their picture's screwed up. And that's because it's looking for, F:// oh, well, that doesn't work anymore. So we were looking at what could support us working with that app while it's, it's not fully running yet, but working through those kind of issues. And then if after go live, if something went wrong, that we could easily switch back to on-prem. So with this tool that did bidirectional sync, we could do that. But it did have some limitations in our schema. So before we even introduced that tool, we went and fixed some schema issues that would have prevented that use of the tool, but actually wound up improving our database in the long term. Azure SQL does not support SQL Server Agent. And at the time, so at the time, everyone knows SQL Agents isn't very fun to work with from just a DevOps perspective. It's annoying to deploy. So they already knew that they wanted to get rid of it. So this kind of accelerated and said, take those existing SQL Server Agent jobs, which are just console apps, convert those into Hangfire jobs, which they already had going, and then do all that work on-prem before you get to Azure. So we did a lot of upfront prep work to kind of modernize in place to get it kind of prepped for the migration, because not just because of limitations, but it also just meant like we weren't changing too many things on deployment. So we didn't want to have a switchover of like on-prem is running agent, and then the day of go live, suddenly it's a Hangfire job. Like, no, we wanted the go live to be just a DNS switch, like bloop, DNS switches, but everything else should be like exactly as is.
Yeah. So real quick, can you tell us what Hangfire is? Because I'm sure there's developers out there who've never used Hangfire before.
Oh, sure. So Hangfire is middleware that can run in your ASP.NET and ASP.NET Core application that can run background tasks. And those background tasks can be run on all sorts of schedules. They can be run on triggers. They can be run on like, a cron-based schedule. They can even run off like, they can be hooked up to queues. So if you have, MSMQ or Azure MQ or RabbitMQ, you can have, different triggers for those. So it's interesting in that it runs inside of your ASP.NET or ASP.NET Core application. So you don't have to have like this other thing that runs somewhere else.
Yeah.
And so for them, like, for big messaging folks, you'd want to have those messaging endpoints run separately to scale independently. But if you have lower traffic, that's not going to take up a lot of resources away. And the Hangfire is a great option. So yeah, we said, let's convert all those to something that can easily migrate up to cloud. Like all their jobs and queues were also inside of SQL. So they just came over with the migration as well. So we said, let's just pick something. Let's get off of these features you don't want to use anyway. Like you already knew it was a pain. And so when you go into Azure, these past things, they're like, well, we don't support the things that are annoying to deal with, which is fine. Yeah, it was good anyway.
Now, modern ASP.NET developers are thinking, wait a minute, that's what I use service workers for. So what's the difference, and how should people think about that?
So I guess in the Hangfire side of things, because it's a lot more flexible in its triggers and scheduling. So if you want to have a job that goes every hour, or if you want to have it like these very specific triggers, like in your code, you could say, just queue this job, and this job is just a method call alongside your regular code. It's just a very kind of easy, low impact way of introducing these background jobs. And it has this nice dashboard. So they have a dashboard UI that lets you see the jobs, anything that's failed, you can retry them as well. And so they'd already been using that on-prem. And so it's a natural thing to like, well, just convert the rest of the things over, and let's get off a SQL Server agent first on-prem. So it's just one less thing we have to worry about dealing with in the day we go live in Azure.
Yeah. Okay.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery. ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
So on the database side, was it ever tempting to think about, you know what, SQL Server, all right, we're modernizing. Do we need to stick with SQL Server, or why don't we just take all this relational database and put it in a NoSQL database? I mean, wouldn't it be cool to use one of those technologies? Wouldn't that be fun? How do you think about that? And how did you ultimately decide, no, we need to keep it in a SQL schema?
So there, you go to, add resource in Azure, and that list is so long of the things that are available for you to use now.
Yep.
And so we had another kind of upfront decision of saying, we're not going to pick any kind of new toys in Azure past just the sort of pure conversion of our existing compute and storage resources into Azure, which meant like on-prem IIS apps, go to App Services, on-prem SQL database, go to Azure SQL, on-prem file share, we had one of those things, then went to Azure Files. So each of us said, let's try to pick kind of like for like, still pass like for like. And then if we're forced to pick something new in Azure, we would. So that actually did come up. So they had a load balanced web app that used SignalR, but it's ASP.NET 4.8 version of SignalR.
Yeah.
Um, so with the .NET migration, that meant as well, like, okay, how do we manage SignalR across different versions of Azure? I'm sorry, of 4.5 and 4.8. And we found out that the scale out option of SignalR was to use SQL as your kind of backplane for messages.
Mm-hmm.
Is not supported in Azure.
Okay.
So like they have some piece of code inside ASP.NET SignalR that says if your server is not a standard or enterprise edition, you cannot use SignalR with SQL scale out.
Yeah.
And so there's no technical reason. There's just an if, and I found it. So we said, okay, so when we go live in Azure, even for the 4.8 apps, we still have to use Azure SignalR for that piece.
Mm-hmm.
So like we weren't planning on it. Like we just thought, just one less moving piece, but we were forced to use that. There are other things we were really excited about getting in place, but just decided to wait. It's like Key Vault for secrets.
Mm-hmm.
We didn't want to, like sort of traditional way of using it on-prem is to go something like deployment variables that are secrets. And we said, no, okay, we can use Key Vault, but let's wait until after we're live in production. And then we can start adding the new hotness. And so the new hotness is like Key Vault, Azure Redis for caching.
Mm-hmm.
Those are the two big ones. Were Key Vault, Redis, Azure App Configuration. We just kind of looked at all the things we could do. What can we do to improve some of these things? We said, no, look, we're going to wait until we're in Azure, and then we'll have kind of a follow-on, like let's do architectural improvements now that we're in an environment that we're not having to test in two places, have feature flags everywhere about, if you're on-prem, don't you do this. If you're in Azure, do that. We'll wait till we're there. Then we can start to innovate in that stack.
Mm-hmm. Okay. Now, besides the Hangfire jobs, did that system include any asynchronous durable messaging handlers and message queues that had to be modernized?
There weren't, but it's something we did look at for the kind of post-migration to say, the downside of Hangfire is that it consumes the resources of your web app.
Yep.
So that's fine if your web app doesn't have a ton of traffic. But you start to look at, the App Insights data to see, is my Hangfire stuff consuming too much?
Mm-hmm.
And so that's something we decided to just keep an eye on and say, well, Hangfire supports queues, and you don't actually have to run the Hangfire jobs inside of the same host as the application. So Hangfire supports a, say Azure container app
mm-hmm.
that just runs the Hangfire jobs.
Yeah.
And then your web app is just queuing things up for the work to be done. It fully supports that. We just wanted to wait to prove that we needed it before, because it would have taken quite a bit of work to convert those jobs, to split them out where they were before. So we just decided to wait till we prove it that we needed it, but put it on the thing of like, we should keep an eye on this,
right?
Just in case.
Yeah, it's interesting that we called it ASP.NET Core, but in creating the host builder and actually starting up whatever application, if we don't actually start up anything that's webby, then you just get a program that sits there and does stuff. But
exactly.
So, which is what you need. Way back in the day, we had these Windows services when you needed something that just sat there and did stuff. And now, whatever sits there and does stuff includes backend services as well as code that serves web pages.
Oh, I did want to talk real quick about their system web adapters, about how they enable easy migration of controllers and actions.
Okay.
So this is kind of the wild part. So the way it works is you can do this in Visual Studio. You don't have to, but you can right-click a project, a .NET 4.8 project, and say migrate. And what this will do is create a .NET 7 application alongside your .NET Framework application. And this is an ASP.NET Core 7 web application
mm-hmm.
that has some extra projects, extra package references, and it's the system web adapters. Now, these web adapters, the way they work is it adds middleware to your .NET 7 application to determine if the request was successfully handled by your application. And if it's not, it uses YARP, which is yet another reverse proxy, to forward that request to your .NET Framework application. So as we bring controllers over, they just start getting magically handled by the .NET 7 application without us having to do extra work to register that stuff anywhere. It just like now the new app gets it versus the old app, and it just works. Everything like signal our work transparently. It all just like forwarded those requests perfectly over to the backend application. It was kind of crazy seeing it all work in action.
You know, what's even more crazy is the episode that listeners listened to just before this one was a dedicated interview with Jay Tower, and he was going in detail about YARP. So,
oh, awesome! Yeah.
So now we have a second success story to add to it. So anybody who hasn't used it, who's looking, then it sounds like it's not just a new technology that it sort of works, but that you found that it works, it's stable, it did its job well, and that was a good thing.
We never like YARP was the whole YARP. I mean, all I did was say system dot or service setting services dot add system web adapters and services that use system web adapters. And then like the reverse proxy was set up for us, and there's nothing else we had to do. The only wrinkle we ever hit was that if your .NET 7 app has a non-success response, it will automatically forward that over. So if you return if there's a 500, for example, then it'll forward that over anyway. And we're like, oh, we don't necessarily want that. So we had this question of do we leave the old controller there? Because you have to delete that code. And we found like, well, if we get an exception, we still see a success page. And we're like, wait, I thought I see an error in App Insights, but it's returning the page. And we realized, oh, the old app is still handling it, but we just didn't know it. It was so transparent. We had no idea. So from there on out, we found up deleting the other pages just to make sure that if we get an error, it stays an error.
Nice. Now, you mentioned App Insights. My next question is, when you were modernizing this thing, were you thinking about open telemetry, or what type of observability architectures were you thinking, okay, we need to put some extra things in place that maybe were not in the older app?
Yeah, so their existing code base, luckily in a lot of places, was using Microsoft extensions logging. So the whole new iLogger, whatever stuff from Microsoft.
Yep.
But their existing observability was log to a table, a SQL Server table, and for exceptions, post a message to a chat room so they could see the message in the chat room. So we're like, okay, we don't necessarily want to, on day one, remove all those pieces.
Yep.
So what we wind up doing is adding a custom logger provider to preserve their existing way of logging, and then laying on top of that App Insights, so that they get used to, okay, here's what it's going to look like over here. But if I still need to go back to my kind of an old observability tool, then that was still there, SQL, whatever, with the intent that like after a month or two, they just remove those custom logging providers, but all the application code was just, iLogger of T. They were none the wiser. I mean, the code was none the wiser, I should say.
Yeah. Well, when they call you back in 15 to 20 years, you'll see that chat room is still going.
Exactly. But it was like the huge thing to see traces and App Insights. Like they never had that before. Like, you can see the request, and you can see all the SQL calls, and you can see the outgoing calls to other APIs in one single view. That was impossible for them before because they only had logging. They didn't have tracing.
Right. Okay. So a lot of people have not used App Insights before, or they think, all of my software has to be in Azure in order for App Insights to be useful, or if they have, it's just iLogger info, and it might as well be just logging to a text file up in the cloud. But it has so many more features than that. What are your favorite features where you find them to be really useful, where okay, your next project, you're likely to use this set of features in App Insights?
So one of the greatest things we saw was, and they had this in their existing system, which was I went to their log table, TBL log, and there was there's the message, which is like in text of just here's the stack trace and whatever you want to throw in there.
Yeah.
But then they also had individual columns for other things they wanted to query on. So what we wound up doing is creating some middleware for, it wasn't App Insights. This is the open telemetry part. We used the activity API to convert all of those where they were stuffing things in individual columns. We converted those to tags in the activities, so that when they went to App Insights, they still had the ability to query over what IP address was it from, who was the user that it came from, like what's business level data. They had that initially, but we converted that all to tags instead of App Insights, so they could easily query of this kind of like top level sets of like telemetry data for them.
Yeah. Man, that's so useful in so many areas. Yeah, we can see that, oh, the system outputted this message, but it's so much more useful to say, no, what I'm looking at is Billy just clicked this button on this page, and this was what he was trying to do.
Yeah, I try to, like, as much as possible, drill into them that if you're trying to search based off a time span, then your data does not have enough cardinality, good enough cardinality. You need to be able to, like, what are the things you want to ask the user? Like, oh, what computer are you on? What IP address? What was your login? Like, those can all be things you can query off of. So you're not just like needle in a haystack. What happened in these 30 minutes? Here's 10,000 messages you have to go dig through to try to figure out which one's which.
Right. Now, did this system include any OLAP data sources or reporting or analytical data that had to be modernized?
Luckily, I say luckily, there were reporting users of the data, but they had an existing system to pull that data out. We did see the system and say, okay, this is a completely different group inside the organization.
Mm-hmm.
So at some point, we were looking at, okay, you should probably put this in some kind of Azure, data warehouse and use something like Azure Data Factory to do this work that you put in all these SSIS packages. But that's for future stuff. For now, we just enable the same connectivity that they had before, which I think was like linked servers or something to pull in the data. I can't remember, but it's like, make sure we have actual, we created, reporting users inside of Azure SQL that only had read-only access to the data, and to enable the scenario for them where all they had to do was change the host or server name inside of their import tool, and then it could still suck in the data. So we tried to have as minimal impact as possible for them because they just weren't ready for that level of modernization yet.
Yeah. Okay. What did that do to your automated DevOps environment? What were the kind of the major steps, and how did you find what major tools, and how did you stitch that together?
Yeah, so initially when we first started the project, they were on-prem Bitbucket, on-prem TeamCity, and on-prem Jira, on-prem, like all the Atlassian tool set. So we wanted to look at, okay, as part of our apps going to cloud, we should also probably look at your other like related CI/CD processes to get those cloud as well. Like, because there's plenty of things you can do now with Azure DevOps. So we looked at is, okay, source control, CI, CD. Let's investigate moving to the cloud, and as much as possible, push it that direction. So we wound up moving from on-prem Bitbucket to cloud GitHub. Okay. We went from on-prem TeamCity for CI and CD to Azure DevOps pipelines and the release pipelines for CI and CD.
Okay.
And really, the decisions around there were, what are your existing processes and gates and things like that, and what supports it up in the cloud, and also what do you have enterprise agreements for already? Yeah. So they already had an existing enterprise organization for GitHub. So we're like, well, let's not introduce yet another cloud Git provider in Azure DevOps. So we didn't do GitHub, or we didn't do Git for Azure DevOps. We did GitHub. And then for that, a lot of those tools were relatively straightforward to pull over. Like GitHub, if you want to import a repository, you can give it the URL, and if you can authenticate, it will suck it all in. So that's what they did, is they, complete history back to like 2009 or 8 or something of this repository. I mean, I had like Subversion way back then. That's, it got converted to Git. So it just, sucked it all in. And then for their, it's one of those things of like, okay, every Friday, everyone push your branches that you want to get imported. And everyone did. And then we just pointed our TeamCity builds over to GitHub and made that the first step. So, going from Bitbucket to GitHub, and then had everyone update the remotes in their, the local machines. The other ones for CI/CD, those are a bit easier because we said Azure DevOps for Azure, TeamCity for on-prem. And so we just developed parallel build and deploy pipelines because they were both deploying to independent environments. At no point do we consider TeamCity to Azure or Azure DevOps to on-prem. We just said have two different pipelines, and so they're not trying to mess with each other at all.
Was there any point where the new system had to be, quote, cut over and people needed to stop using the old system to do the new one? Was there ever a break, or were you able to do it completely seamless all the way through?
I'd say it's a minimal downtime cutover. So we knew that the import of data, like we knew we needed to stop the system, but they were used to doing that already, because they'd have cases like adding a new column to a table with 1 million rows. So like, well, we need to have the user stop it because we have to seed that data, and that takes some time. Yeah. So they just do it off hours. It wasn't, all the time, but for these cases where they had, complex data migrations, they'd have to do it. So they already had the capabilities to take the system offline. For this, though, we knew that it's not like we could take the system offline and import the data over, because that could take hours and hours. Mm-hmm. So we wanted to have more of a minimal, like 30 minutes or less sort of downtime. So that's what we did. We took the app offline, put up a maintenance page. Then we took the apps offline, so we stopped them, mainly because we want to make sure the Hangfire jobs stopped as well. Mm-hmm. If you just throw an offline page, like Hangfire will still run. So we stopped it. We did a final sync for data. So we've been doing ongoing Delta syncs this whole time. And so just before we flipped the switch, we said, okay, do a sync, hit the switch, and then it's only going to be getting 15, 20 minutes of data that has to sync over for files and data. And then it was just a DNS switch. So DNS switch over to the new system, bring it online, and it was done. So we wanted to be as seamless as possible. I think our downtime was, maybe 20, 30 minutes, something like that. Mm-hmm.
Now, was that cut over 0 to 100%? Was that cut over at the very end? Was it at the 50% mark, or was it much at the very beginning in the early stages?
It was basically at the end, but that was, so we had the two work streams. One is the .NET 7 migration, and one is the Azure migration. Okay. It was just pure coincidence that the .NET migration finished like the week before going live in Azure, but we didn't plan on that. We had in Azure, we had the proxy app and the .NET framework app deployed and out there. Mm-hmm. It just so happened when we cut over, we finished just purely by accident. We did have to work with their existing processes, and there had feature work still going on mm-hmm. as well. So we had to make sure that we didn't go too terribly long from when we started the migration to we finished. So I think we had the kind of the dev environments, and then 2 weeks until the stage environments. That's when we did all of our regression testing mm-hmm. with actual live whatever. And then it was 5 days later was production. So we did a Thursday release of stage, and then a Tuesday release production. Okay.
Total project duration, calendar time?
Probably 5 months, something like that.
Okay.
5 to 6 months. So the .NET 7 migration, we finished out in about 3 or 4 months. Mm-hmm. And post, it's probably 6 or 7 months, because post go live, we also said, okay, let's go ahead and get that key vault in place. Let's actually get that Redis in place. Well, that didn't actually work out for us for some reason. Go get all the disaster recovery processes in place as well. So that, we went live, and then had a month and a half of just okay, let's do some innovation in here while we can.
Right. Awesome. Man, this is a great success story, and lots of good detail about what's worked and techniques and the options, and because everybody's going to make different decisions based on the tension points and the options and what they've done before and the skill set of the people they have. So I appreciate you coming on and sharing straight from the trenches.
Of course. Love the chat.
Absolutely. So being out of time, we'll kind of wrap it up. And we'll put all the different tools and such that we talked about in the show notes. But yeah, appreciate you coming back on the show and sharing with us about .NET 7 and Azure modernization.
All right, anytime.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.